Okay, this is worksheet 2 on our vectors and projectile unit, and it's called addition of vectors. When you're looking at a drawing of vectors, as on the first question on addition of vectors worksheets, they show you a diagram such as this that has 3 vectors connecting, and you can see the heads and the tails of each vector. And so what they said is that you can't they hadn't labeled them properly as far as which is the resultant. So how can you determine which vectors are the vectors that are being added together and which vectors are the resultant? When we're talking about adding vectors together, we always start with from a head to tail direction. A tail to head direction. So this would be a tail of the vector to the head of the vector, and then this vector comes off the head and goes in this direction. So where you see the point where 2 heads come together, you know that one of these vectors will be the resultant. The resultant is always drawn from the starting point to the ending point. So in this one we can tell that vector A is the resultant. You can see that these 2 are connected, tail, head, and then these 2 heads come together. This would be the end point, and this would be the start point. So vector A would be our resultant vector. If we're trying to determine the angle for this, we would just draw in a straight line. We can get our protractor and measure the angle here. Again, putting our center of our protractor on the beginning of the angle and reading across here, we get about 20 degrees. The next problem talks about adding 3 different vectors together, and you can do any of the 3 to get a resultant. Now it doesn't matter when you're adding vectors, it doesn't matter what order you add them in. So if we add vector A, which just goes in a straight line like this, and we add vector B, which goes in a direction like this, and then we add vector D, which would go in a direction like that. So again, we drew them all head to tail, and then the resultant vector will go from the starting point to the ending point. And so this would be the resultant vector. Just to show you that it doesn't matter what order we do them in, we'll start with vector D, and then we can do vector B, and then do vector A. And again, our resultant vector would be there. When we talk mathematically about adding vectors together, we are going to use our Pythagorean theorem. We went over the Pythagorean theorem in class, but just to refresh you, the Pythagorean theorem has to do with our right triangles, this being the right angle, and this being side C, side A, side B. Pythagorean theorem says the square of the hypotenuse, the long side that doesn't touch the right angle, equals the sum of the 2 other sides. So using our Pythagorean theorem, we can look at the problem of our friend Dexter who's on a camping trip, and it says in problem A that Dexter walks 50 meters at a direction of 225 degrees. So we know again from our cardinal directions that horizontal is going to be 180, so 225 degrees, if we got our protractor out, is going to be this direction, and we know that he walked 50 meters at 225 degrees, and then it says he walked 20 meters at a direction of 315 degrees. So he then turned at an angle of 315 degrees, and he walked 20 meters. And so it wants to know what is our resultant vector. So we know that our resultant is drawn from the starting point to the ending point, and we know using Pythagorean theorem that this is also can be C or can be A, so the square of the resultant is going to be the square of 50 meters. Be sure when you write it you include your parentheses, otherwise the tendency is to read it as 50 meters squared instead of 50 meters squared. Plus 20 meters squared. So that will give us 290 meters squared. And we take the square root of both sides. We find out the resultant is 54 meters. Be sure you know how to work your calculator in order to do this problem.